students. IIT-JEE NEET Foundation. See, today topic is electricity. In the physics, electricity, electric power. See, electric power is nothing but rate of work done. The rate of electrical work done is called electric power. See, in our domestic applications you take, in the day-to-day life, you take fan, there is a power will be given in the box, and you take bulbs, there is a power 100-watt bulb or 60-watt or so etc. These are power consumption is also very important. Okay, normally when you are taking a big electrical devices, like see, huge power, if you are consuming, more electricity bill will come. So naturally power is very, see how much power you are using in your home or in industries etc. They calculate based on the power consumption only. So that's power, the rate of electrical work done, how much you are consuming and how much time you are utilizing. So based on that the calculation will be done. So the electrical power, the formula, basic formula in the electrical power, the DC electrical power you take. There is a AC electrical power will be different and DC, because usually the sources like resistors, all these are DC sources, DC related circuit elements. So that DC power is equal to voltage into current. Power is equal to voltage into current. Power has, see, there is a triangle also there, magic triangle, like see power, if you take a power formula, see power is here and voltage and current. Power is equal to voltage into current. Voltage is nothing but power upon current, and current is equal to power upon voltage. See, this also will have three formulas, like see power is equal to voltage into current. So voltage can be written as current into resistance into current. So it is nothing but power is equal to I square R. See, square of the current into resistance, square of the current into resistance. This is another formula. So similarly you can write in terms of, see, voltage into current. Current can be written as voltage by resistance. It means power is equal to voltage V square by R. So V square by R. This is another formula, voltage square divided by resistance. Voltage square by resistance. So power has three formulas. If you are using the formula V into I and I square R, that is equal to V square by R. All are the power formulas only, don't get confused, all are similar. Power is equal to voltage into current. See, the unit of power is watts, the unit of power is watts, the unit of voltage is volts, the unit of current is ampere. 1 watt equal to 1 volt 1 ampere. 1 watt is equal to 1 volt 1 ampere. See, coming to the problem here, let us take, if you take a voltage of, see, voltage of 100 volts, if you take, for example, if you take 100 volts and current is 5 amperes, you take current is 5 amperes, then what will be the power? See, the power is equal to 100 into 5, 500 watts. Power is equal to 100 into 5, 500 watts. Simple. Power is nothing but voltage into current. Voltage is 100 and current is 5. 100 into 5, 500 amps. See, if you try to find out in other way, for example, you take, see, now instead of power you take 500 watts, you take the volts. Voltage you take it as 20 volts. You take only 20 volts. See, then what will be the value of current? Power is, see, if you take power is 500 watts, power is 500 watts and voltage is 20, then current is equal to, how much? Current is 25 amperes. The current is 25 amperes. See, you can understand here, there is power is equal to voltage into ampere. Voltage is nothing but joules per coulomb. Voltage formula, work by charge. Voltage is nothing but work by charge. Work is measured in joules, charge is measured in coulombs. Voltage can be written as joule per coulomb. Joule per coulomb, ampere is nothing but rate of flow of charge. The current coulomb per second. Coulomb per second. Coulomb get cancelled. Joule per second. Joule per second is nothing but watt. Joule per second is nothing but watt. You can have like this the conversions, unit conversions and all these things. And power in the resistor, this is very important. I have given just now the formula. Power is equal to voltage into current, V square by R and I square R. So these are the normally power formulas. See, power in the resistor. Yeah. Yeah, DC circuits, resistors, resistor combinations, of course, power dissipated, this we already discussed. Example of power in series and parallel resistors. If the resistors are connected in series, if the resistors are connected in parallel, how the power relationship will be there in the series and parallel circuits. Just we'll take one example here. See, it is going to follow the main tools to solve such problems. We require Ohm's law. Ohm's law is nothing but voltage is equal to current into resistance. Another important voltage law. Voltage law, algebraic sum of all voltages in the loop is equal to 0. Algebraic sum of all voltages in the loop is equal to 0. And current law. What is current law? The current sum of incoming currents at a junction is equal to sum of outgoing currents. See, algebraic sum of all currents at a junction is equal to 0. Algebraic sum of all currents at a junction is equal to 0. These are the tools you are going to solve such problems. See, let us take the problem is this. Just understand the problem. Very simple problem. So here how power relationship will be there in the series and parallel. Simply explains. Let us take R1 and R2 are the resistors. Here R1 and R2 are the resistors. R1 is 6 ohms, R2 is 2 ohms. R1 is 6, R2 is 2 ohms. See, there is a 12 volt current is there. 12 volt potential difference applied across the battery. So now the R1 and R2 are connected in parallel. R1 and R2 are connected in parallel. If R1 and R2 are connected in parallel, effective resistance is what? Effective resistance in parallel connection R1 R2 by R1 plus R2. R1 R2 by R1 plus R2. Just I will explain how you got these values. R1 is nothing but 6 and R2 is nothing but 2. 6 into 2 by 6 plus 2. So 6 into 2 is 12. And 6 plus 2 is 8, 12 by 8. See, this is the effective resistance 12 by 8. But what you want actually current, see from the battery how much it is coming. So total voltage, current is nothing but total voltage divided by total resistance, effective resistance. See, total voltage is how much? The total voltage is 12 volts. 12 volt by resistance is 12 by 8. So if you simplify 12 get cancelled. So 8 amperes, the current from the battery. See, the current from the battery is 8 amperes. You got the 8 amperes? So once this 8 amperes comes from this. So there are two resistance. One is R1, another is R2. So R1 is 6, R2 is 2. See, now try to this current 8 amperes split it into two currents. Because the parallel circuit current is going to be divided. When current is divided, 8 amperes, 2 amperes will go to the R1 resistor and 6 amperes will go to the R2 resistor. How can you say 2 amperes only is going to the R1 resistor? See, 2 amperes is going to R1 resistor, you can find like this. See, I1 if you try to find out, voltage divided by R1 if you take. Voltage is, total voltage is how much? 12. So resistance is how much? Resistance is 6. So it means See 6 2 is 12, 2 amperes, the 2 amperes of the current is coming out. So it means here across R1 2 amperes will is, similarly if out of 8 2 amperes is gone to the R1, then 8 minus 2 is 6 amperes. 6 amperes will go to R2. So in this way you got the current values. After getting the current values, how power is distributed? So power is nothing but the power from the battery. How much it is? Power is nothing but voltage into current. See, voltage is 12 volts, current is 8 amperes. So 12 into 8, that is 96 watts. See, 96 watts is coming. In this 96 watts, see R1 how much it is sharing and R2 how much it is sharing. So to find out that, see 96 is divided into two parts. 96 is divided into two parts. So to find out that voltage across, again power across, this is power will be, see voltage is remains same in the parallel, voltage is remains same. That's why 12 into the current is 2 amperes, 12 into 2 24 watts. See out of 96 24 is, so 24 watts through the R1. So 96 minus 24, that is 72. So 72 watts will be there in R2, means power is also divided in the parallel. See power is also divided. Total power is equal to sum of individual powers. Total power is equal to sum of individual powers. 96 watts is divided into 24 watts and 72 watts. In this way, so the values, the power is going to be distributed in the parallel connection. Similarly, you take in the series connection. In the series connection, the same 6 ohms and 2 amperes are there. 6 ohms and 2 ohms are there. So 12 volts is the battery. So this 12 volts is coming through this and the current is 1.5 amperes. How you got this 1.5? Effective resistance you calculate. Effective resistance in series connection R1 plus R2. It means 6 plus 2. So 6 plus 2, that is nothing but 8 ohms. 8 ohms is the effective resistance. Once you got 8 ohms, then current is nothing but voltage by resistance. Total voltage is 12 by 8. It is nothing but 1.5 amperes. So 1.5 amperes is coming out of that. So it means that the voltage is 12 volts, current is 1.5. The total power transmitted, the power transmitted is voltage into current. Voltage is 12 into 1.5. It means 18 watts is coming only. See, in the series connection only 18 watts will come to the circuit. In that 18 watts, the current will be same. So 1.5 amperes current is going to pass through that. That's why voltage here, if you try to calculate voltage drop across this, how can you find out voltage drop? Voltage is nothing but, if you try to find out that, see this 9 volt drop, how you got? See voltage across first resistance, current into R1, IR1, because same current travels through the circuit in series. Current is 1.5 amperes, resistance is 6 ohms. 6 into 1.5, 9 volts. So voltage drop across the first resistor is 9 volts. Similarly, voltage across second resistor is, out of 12, 9 is, so voltage is divided. 12, 9 is gone. So 12 minus 9, that becomes 3. So 9 volts here and 3 volts here. This is the voltage distribution. Once you got voltages, now you can find out power. The power across the first resistance, power is nothing but voltage into current. Voltage is 9 volts, current is 1.5. So 9 into 1.5. 9 into 1.5. Here voltage is here 3 volts into 1.5. So 3 into 1.5 is how much? 4.5. See total is 18 watts. 18 minus 4.5. So that value 9 5 is 45. So 13.5 and 4.5. It is going to be distributed. 18 watts distributed in this manner in the series connection. So power is distributed in this manner. So in resistance are connected in parallel and resistance are connected in series. I hope you understand. So this is about power circuits. So thank you very much. Thanks for watching this video. We'll continue in the next video.